Hey guys, welcome back. Today we're going to talk about arithmetic operators. When we say the word arithmetic, we're thinking like math. We're talking about manipulating data. With operators, we're talking about like something that performs an operation like multiplication, division, addition, subtraction, stuff like that. The first thing we want to talk about is modulus. It's a new operator that we're adding into our toolbox. And what it does is it gets the remainder of the division. So if I were to say, and we write the modulus operator with a percent sign, I know it's a little confusing, but if I say 7 modulus 2, 7 divided by 2 is 3. It goes into 7 three times with 1 left over. So modulus gets the remainder. 7 mod 2 is equal to 1 because there's one left over. 6 mod 2, here, 2 goes into 6 evenly 3 times, and so the remainder is 0. So 6 mod 2 would be 0. Let's look at a few more examples. So here, don't worry about this stuff down here. We're looking up here at the modulus section. We've got 5 mod 2 right here. 5 mod 2 is going to give me a 1 because 2 will go into 5 2 times with 1 left over. Now if I swap that and I do 2 mod 5, that gives me a 2. And here's why. 5 won't go into 2 at all. Therefore, the 2 is what's left over. So if you have a case where essentially the left side, the left number, is bigger than the number on the number on the right is bigger than the number on the left. Let's do this one. What's left over is the original number. Is because there is no, like, it doesn't divide at all, and so what's left over is the entire thing, if that makes sense. Okay, what about if we mod by 0? Sorry, this is written wrong. It should say a 1. Let's see, what if we mod by 1? If I mod by 1, that's a remainder of 0 because the 1 goes in there evenly every time. But what if I try to mod by 0? I get an error because we can't divide by 0. It can't figure that. So division by 0 can't happen, and so we're not allowed to mod by 0. Let me change this back. All right, the next thing that we want to talk about, and we'll talk more about modulus later and how we're going to use that in our code, but for right now, all you need to be aware of is what it does and also where it falls in the order of precedence or order of operations. So your textbook goes into more detail about order of precedence. There's a whole chart you can look at, but we're just going to look at the basic operators right now, where they fall. So the first thing that comes up in order of precedence is called unary postfixes, and we'll talk about that at the end of this video. Next, we have multiplicative. So we've got multiplication, division. Notice that modulus falls in with multiplication and division. And then we have addition, subtraction last. So think order of operations, think PEMDAS, and just keep in mind that modulus falls in line with multiplication and division in its order of precedence. All right, let's talk about typecasting. So typecasting has to do with changing one data type to another data type. And there's some reasons why this would happen. One reason this would happen would be if I had an integer. So int equals not my int equals 9. It's an integer. And I tried to store it inside of a double. This is completely possible. And Java does something called widening casting. What that means is it's taking something that's smaller and putting in something bigger. It's widening it. So think back to when we were talking about data types and their sizes. Doubles were way bigger than integers. Okay, they could hold way more data. Doubles can. So we can store something small inside something big. And so what happens is it simply changes that 9 to a 9.0. So if we look here, if 9 casts as a double, so casting is the process of changing its data type. Java does this for us. So let's look at that code here. Here's what the code would look like here. I'm simply taking the 9 and then I'm setting that double equal to it. And Java will convert it for me or cast it for me. Now let's look at another example. What if we're going the other way? What if I start out with a double, which is really big, and I try to store that inside of an integer? So look here. Put that back for now. So look here. I start out with a double, 9.78, and then I try to store it inside of an int. If I try to do that, if I take that out, it won't work. It immediately throws me an error. It says you can't do that. It actually says cannot convert from double to int. So Java can't do that on its own. This is called narrowing. We're going from a bigger data type to a smaller, and it can't do that. We can't store something really big in a really small package. And so in order to do this or make it work, we have to manually cast the number. Java won't do it for us. So when we cast, we do it just like this. So here I'm going to take this number and I'm going to cast it as an integer here. We always do the casting on the left-hand side, and we put inside parentheses what we want to cast it as. So if I wanted to cast it as a double, I'd put double. If I wanted to cast it as a short, I could do that. Put a short in there, long, whatever. But what's going to work here is casting as an integer because I want to store it as an integer. And then of course it works out if I do that. But that's called narrowing, going from big to small. And I have to do this manually. And this is how I manually cast something to a different data type. Put the data type you want to cast to inside the parentheses. Okay, next. Integer division. This is going to come up quite a lot. What happens is, if I have an integer, say 5, and I divide it by 2. Now, whenever Java sees a number without a decimal, so here I just have a 2. Let's look at it in the code, actually. So here I just have a 2. If I don't have a decimal on that, Java reads it as an integer. If I had it like this, it would read it as a double. But because there's no decimal, Java assumes that 2 is an integer. So what I have here essentially is an integer, num, and another integer, 2. When Java does this math, watch what happens. So I'm doing 5 divided by 2, right? Let's see what happens here. 5 divided by 2. It says that 5 divided by 2 is a 2. We know that's not true. 5 divided by 2 is 2.5. So what actually happens is called integer division. Java assumes that if I have 2 integers, I want the result to be an integer as well. And because of that, I can't have the 0.5. So Java simply drops the 0.5 off the number. It doesn't round it. If it rounded it, this would have come out to a 3. But all it does is drops the decimal. So integer division, when you have 2 integers and they're divided, Java assumes the answer should be an integer. It simply loses the decimal. It doesn't round it. Okay, so there's 2 ways I can fix this though. Remember, this only happens when I have 2 integers. So what I have to do to fix it is just simply convert one of these into a double or something else, something with a decimal. If I convert one of them to a double or a float, it'll fix it. So here's an example of how I could fix this. The top example, I could add a 0.0 to the 2. That would make Java assume this is a double, and therefore it won't do integer division. Another way that I could fix it is through casting. If I cast one of these numbers as a double, like this, then now I have a double and an integer, and it won't do integer division. I could also do both. So I could do this, and it would still work fine. As long as one or both of those numbers is not an integer, is a double or a decimal, it won't do integer division. And as you can see, it'll do the correct math. All right. Next thing we want to take a look at is combined assignment operators. So all these are easier ways or shorthand ways to write some of this math. So if I had x equals x plus 2, a simplified way that I can do that in Java is x plus equals 2. And you're probably like, Mr. Jones, that's only saving me one character. I'm only saving like a little bit of space here. It's because we do this type of math a lot, where we increment a value like a lot, like by just a set amount over several times. And so because it's something we do a lot, they give us a shorthand way to do it. And yeah, it's just saving one character, but that, we'll take what we can get. So let's see that in practice. All right, so here, let me make some space here. Come on, Simon Operators. Okay, we're going to start with this x here, right? So right here, I have x equals 5. X equals 5. And what I'm going to do first is I'm sorry if you hear that stupid water running in the next door. I'm going to do x plus 5 here. So here's my math, x equals x plus 5. And then I'm going to simply output what x is. So executing x equals x plus 5. So I'm adding 5. I'm taking the current value, adding 5 to it. So now it's a 10. Another way so that's right here. I can also do x plus equals 5 here on line 52. If you'll notice, that does the exact same thing. Now it's a 15. I added 5 more. Okay, another compound operator is minus minus and plus plus. These are called postfixes. And if you remember up here at the top, so here, I've got x plus plus, is the same as saying x equals x plus 1. So I could write that as x plus equals 1 or x plus plus. And remember, these are called postfixes, meaning they come after the variable. And if you remember, here's where these fall in order of operations. They happen first. So if you happen to have some of these together where it's doing a postfix and it's multiplying and it's adding or something like that, keep in mind that postfixes have a higher order of precedence than multiplication and addition and subtraction. Okay, so here's how they work. X plus plus always adds 1, and x minus minus always subtracts 1. They only work with adding 1 and subtracting 1. And so here, remember, I was at x is 15. On line 56, I do x plus plus. So now x is a 16. And then here I'm doing x minus minus. So now x is a 15 again. Mr. Jones, why don't they just do x plus equals 1? What's with the shorter way there? Okay, here's why. There are even more times, more situations where we have to add 1 and subtract 1. And that'll make way more sense later when we get to loops and things like that in iteration. We increment by ones a lot. We go up by ones and count down by ones. So it's a way for us to count. Since we do that a lot, again, they give us a really short way, or really efficient way to write that code by simply doing plus plus and minus minus.